Hey everyone, welcome to a live stream with Soracom. I'm really excited. We've got some awesome stuff we're going to do today. I'm just going to give a minute for people to come in on the live stream. We're going to have Dr. Sami Mian join us in a few minutes, and he's going to do a live build with us. So I've put together an example that uses our Soracom IoT Starter Kit and AWS Lambda to create kind of an IoT alert automation system. We'll get into it in a little bit, but while we do that, I want to talk a little bit about what Soracom is for anybody who probably hasn't seen this yet. So I'm going to just share my screen here. So Soracom is a IoT connectivity provider and a cloud platform for building IoT applications and scaling your products. So one of the benefits of Soracom is that when you have a device connected to our network, it's completely secure. Like it's running through our private network, allowing you to authenticate your devices just with the SIM card. You can scale up to whatever amount you want. And with our cloud platform, you can create all sorts of integrations. So we have this thing called a Soracom Unified Endpoint, which is one single endpoint that your device can message out to. And you can configure that to, go into Soracom Func, which is our service for connecting to cloud functions through Azure, Google Cloud Platform, or even AWS. We've also got Soracom Beam that lets you create an MQTT bridge where your device just has to connect to an MQTT broker. You don't have to put any credentials on it. It's using a SIM card. And you can have that bridge to AWS IoT or Adafruit IO or Blink apps. So if you wanted to do, quick, easy IoT application, you can use all of that. We've actually got those examples on our GitHub for the Soracom IoT Starter Kit. So our starter kit is a Arduino MKR 1400 or 1500 and a carrier board and a bunch of these Grove sensors. So it makes it real easy to build a quick application by just plugging and playing. So if you're interested, we actually have a 40% off special on this kit today. So you can go to our website, soracom.io, grab one, and get started building. And we've got all the examples to get you going there. So while we wait for Dr. Sammy to join us, I'll tell you a bit about what we're going to build today. So I just published this repository. We'll be putting more instructions and publishing a Hackster guide to it shortly after the stream. But we're going to build an alert system. So there are situations where you'll have a remote sensor, and that could have all sorts of different ways of detecting, whether it's using a camera or using, in this case, we're going to use an ultrasonic rangefinder, something that occurs that you then want to trigger off a series of events, right? So it might be that you're in a factory and you have a piece of equipment that you have maybe like a accelerometer on there, and you're detecting if there's a certain amount of shake or change. You'd want to detect that, then send that message out, and then do a number of triage operations, right? First, you're going to alert whoever's important to handle the situation. You might trigger other automated systems for safety. You might publish a Slack message. I don't know, right? It could be a number of things. And so doing that might sound complicated and hard, but using the Soracom Cloud Platform, Soracom Connectivity, and AWS Lambda, we can make that really, really straightforward and easy. So this example I have has two components. We have an AWS serverless app, and this is basically, it's a cloud function. So AWS Lambda is a service for, say you want to build an application, normally you would stand up a whole server. And on that server, you would build out an API and do network routing. That's really complicated. So serverless is this thing that's emerged to handle that issue, where you would just have a series of cloud functions that do particular tasks, and there's different ways to gate on how you connect with them. So with Soracom Func, we're going to link directly into a Lambda function and call it directly to the API. So this is why it doesn't have an API built into it. This is a serverless template. So in the Soracom MKR IoT Alarm repository, Soracom Labs, this template is what I use to deploy the application. It basically is definitions for cloud resources that need to be deployed. And so right? We'll look at this. It's got parameters. We give it an email address, and this is the email address we're going to alert on. So what the example sketch we're going to put on the device does, it connects to the Soracom network. Then when the rangefinder detects something that's closer than 50 centimeters or 10 centimeters, it kicks off a message to the Soracom unified endpoint, which then gets forwarded using Soracom Func to this Lambda function. And that Lambda function, all it does is it takes that event, that message from the device, publishes it to an SNS topic. This is a simple notification service within AWS. And with that, we've created a subscription, an email subscription. So that email that will provide it will get subscribed to receive notifications through an SNS topic. And so, right, this function, again, just receives that event, messages an email. Hey, we got Chloe in the comments here. Yes, Lambda functions. So from here, so this template here also creates a managed policy. So with AWS services, you need to have the right permissions to do things like invoke a Lambda function. And for the Soracom platform, Soracom Func, to be able to invoke this Lambda function, it needs those permissions. And so that's why we create this managed policy. And I'll show you in a bit once Sammy gets here. We'll dive into putting this together, where we'll actually create a user with this managed policy and then add that into Soracom. And so here's actually the function, right? It's super simple, just receives the event. And going into the sketch. So I've actually put two versions of the sketch in here, one for the MKR 1400 and one for the MKR 1500. So again, the kit comes in two versions, which is, oh, we've got a raid going on Twitch. Hey, everybody. And so these two versions of this sketch, right? So there's so I'm going to switch cameras real quick. All right. Oh, we've lost my camera. There we go. So these are the two versions of the board that you'll get. So this is the 1400, so this is the MKR GSM. So this one does 2G, 3G, 4G networks. And then we have the newer MKR narrowband 1500. So this one uses narrowband IoT and CADM1 networks. Those are networks specifically made for the Internet of Things. So they're more low bandwidth data, but you can get more range. And the US has actually now got full coverage for those networks. I've actually got a different antenna on this than comes with the kit, just because I live in a Faraday cage. So I have issue getting signal. So when we do get around to building, I'm going to actually have to take this outside with the USB extender. All right. Hey, we got Sammy in, so I'm going to bring him on real quick. Hey, Sammy.
Hey, can you hear me okay?
I can hear you loud and clear, sir.
Excellent. Hey, so glad to be here. I just opened the package you guys sent me with the rope kit, the boards, and the antenna. Have not opened or touched anything yet. This is all new to me. Should be a fun build.
Awesome. Well, since we just got you here, why don't you introduce yourself and what it is you do?
Yeah, I apologize. I would have dressed up if I had time. I've been running since 7 a.m. today. So my name is Sammy. I'm an old friend of Moheeb's. I am actually based out of Arizona as well. Just moved here. My day job, I run engineering for a small drone company out in Texas called Rise. We combine drones with the airline industry for a variety of things. I also do a lot of consulting work on the side in the robotics and AI space. That's kind of my area of expertise. Prior to doing this, I was actually working on my PhD over on the East Coast, doing a lot of drone work for NASA and a few other groups. So I've always been a hardware hacker at heart, and I love building all sorts of things.
Awesome. I'm excited. So I do know that we're going to get the Arduino IDE set up. So I'm going to do a quick walkthrough of the code, and then while you can take some time to download the Arduino library. So I'm going to share my screen again here. So if you want to go to this page, I'm going to drop the link in our private chat. Yeah. So for those watching, we're doing a whole new type of format where we just bring on a guest, give them a kit, and live build with us. So this isn't your typical, like, I'm just walking it through. We're going to have somebody walk through it with us.
Yeah.
So things could go horribly well or horribly bad, but we'll find out.
Have you already gone through the kits and everything that's in them?
All right. Yeah, we've gone through the kit. So, oh yeah, the other great part about this kit, I can't believe I forgot to mention, it comes with a bunch of sensors. So GPS, ultrasonic sensor, a button, magnetic reed switch. What else have we got in here? Digital accelerometer, and a temperature humidity sensor, and a buzzer. Which is not a sensor, more of an output. But. All right. So yeah, if you want to go to this link, and the first thing you want to do is set up the Arduino libraries. So this device, the beauty of it is an Arduino device, if for anyone who's not familiar, is basically it's a microcontroller. It's what's inside electronics. It's something you can program using this kind of code where it's a little bit more simple. So in the past, you would have a microcontroller and you'd have this whole complicated IDE set up. Each chip had its own IDE and its own way of being programmed. And Arduino is this open source project that brought all those boards together, all those different chipsets, and put it under one development environment where you can write one set of code that works on multiple types of boards. And with that, there are some particular things. So this is the latest version of the Arduino IDE. It's the 2.0 beta. And we've already got a sample sketch in here. So one of the things is, before you program it, you have to download the board definition for the SAMD MKR. So if it's your first time doing it, you would type in SAMD, and you go ahead and download, is it this one? Yeah. Let me just actually double check that. Yeah, that goes into the SAMD board. So you would find the SAMD 32-bit ARM Cortex, install that board definition, and then that would allow you to go into tools and select from this list of boards the kind you want to use. So there's a number of different boards that use this chipset. So we're using the MKR narrowband 1500. Then there's a couple of libraries you need. So these are a set of code functions. A library is something that people make as a helper to do specific things, right? There's this underlying layer if you're just flipping pins on and off or reading pins, analog or digital. And so over the years, we have all these libraries that handle all of that for us. So for this particular example, you just need the MKR NB library. And this is provided by Arduino for this board. It's basically a library that handles all the connections and getting a client object.
And Moheeb, so quickly, I see on your GitHub that you have links to these libraries, but it's probably good to specify you don't actually have to download them from GitHub, right? You can find them all.
Correct.
Yes.
You can find all of them in the library manager. And the latest version of the Arduino IDE has also got the Seed Studio libraries included in that registry. Yeah, you just type in the names of those libraries and then install them one by one. So for this one, we need the MKR-NB library, so that handles all the network connections. The Arduino HTTP client. Now this library handles doing all the web requests, so doing things like making REST calls. REST is it's the way the internet works. It's how you make web calls. When you go to a website, you're making a GET request. In this case, our device is going to make a POST request to the Soracom Unified Endpoint API. So this is a web address that links your data to a cloud platform. And then we're also downloading the Arduino JSON library. This lets us pack things. So JSON's a type of data definition. It's basically when you do curly braces and you have your key value pairs. So it's very common in doing any sort of web integrations. So we're downloading the version by Benoit Blanchon. So you'll install that. And then of course the ultrasonic library from Seed Studio. So I think if you just type in Seed and ultrasonic, you should get that. And that's all you need to do for setup on this end. So that gets the IDE set up. I always like to do that first because it takes probably the longest. So after that's set up, you go into the Soracom Dashboard. So if you have a Soracom account, Once you've registered a SIM, you'll see this page. So you guys are seeing all my SIM numbers, so I'll deal with that later. And what's cool is when your device first connects, right, if you have a SIM card, it actually shows you where it is based on the nearest tower. But Sammy, have you created your Soracom account yet, and have you registered your SIM?
I have created my account. I have not registered my SIM. I'll do that right now.
Yeah, well, we should make sure we do that first. So sometimes it can take a minute for a SIM to be active. Oh, I'm loving the comments. You guys are so nice. Yeah, so once a SIM is registered, you're creating a new one. So one of the first things you'll see is an option to add it to a group. Got logged out there. So the way configurations work for forwarding to Soracom Funk or any of the other services we have, the device needs to be in a group. So we're configuring those settings on a group. I've put all of my SIM cards under the Arduino group, and that's just an arbitrary name that I gave it. You can also go and do it after the fact. You can create new groups or set them by selecting it and then hitting details. And while Sammy registers a SIM, I'm going to go through the next step. So once you have that group, you can go to the groups menu from the side, select your group, and in here's where you can do all your configurations. So like I said, there's a unified endpoint. Go down here, and by auto default, this basically says like take the unified endpoint and send it to everything. I could or change what response it gets back. Yeah, that's your SIM.
So you guys are super nice. It looks like Soracom already registered it for me.
Oh, excellent. So perfect. Then what you want to do is go back in those settings, hit details, and create a group for it. And once you have that group in this menu, you can enable a number of features, right? We can do Beam, set it to MQTT. In this case, we're doing Soracom Funk, and we're going to enable that. But to do this, we now need a Lambda function, right? We're saying use Soracom Funk, send it to a Lambda function, construct that as JSON. But then we also need to add credentials. So this is what I was talking about earlier with our AWS application, which I defined in that template. But normally you would deploy this app through like the command line using the SAM CLI. But what I've done is I've published it as a serverless application in the AWS SAR repository. So, Sammy, what stage are you at?
So I got the Arduino IDE up and going, installing the libraries, creating the group for the Soracom SIM. What did you say we need to? You said Funk? We want to enable that?
Yeah, and we're just going to have that ready so we can move over the values we're about to create.
Right.
Okay, then once you're at that point, open up your AWS console.
Pulling that up. And I should preface this by telling everyone that I literally my computer, fresh install of Windows last night. So we're doing everything from scratch.
Nothing up my sleeves. All right, you there?
Almost. So to go to console, and where should I go? You said serverless application repository?
Yes, so yeah. You can also type SAR in the search bar and it'll pop up. All right, and once you're there, you can go to available applications. Be sure to check show-ups that create IAM roles or resource policies. And just type in Soracom. And you should see a Soracom SNS alert. So this is that function where it's just a Lambda function with permissions to publish messages to an SNS topic that's subscribed to that an email address is subscribed to. So it just allows us to do email alerts. But we're going to do it allows us to do some other stuff too, because we'll have a serverless function that we can then edit directly in the cloud here, which is basically a Python function running in the cloud, meaning you could do whatever you can do with Python in that. So you can make REST requests, you can add in libraries for another API or service, and kind of fan out this message from your remote device. All right. Are you here?
It's loading. Okay. The service signup is almost complete. That's strange. I definitely have an AWS account.
Uh-oh.
Maybe we'll both have to use yours.
All right. Yeah. I mean, we can do that. I can just give you the credential, drop you the credentials. So we'll just do that. We'll use my account.
Yeah.
So I'm going to create a function that we can both use. So once you have it, you can click on it here, and this takes you to the menu. So in that template, when I published it, and for anyone just joining us, we're doing just to reset the room real quick, we're building an IoT alert system using AWS Lambda, Soracom IoT Starter Kit, and the Soracom IoT Cloud using the Soracom Funk service. So this is we're going to create our app. So we'll give it a name. In this case, we're going to do live stream. All right. So this is the parameters, and then an email address. So we'll both end up using this email address. So I am going to just use. Actually, this will be fun. Sammy, can I use an email address of yours?
Sure. Personal, edu. Is there? You have a preference?
Let's do personal because I don't know that ASU's email will allow.
Yeah. Okay.
To step in.
Here, I'll let's do SM. Actually, you know what? Let's do SMIAN. So my last name. 17 @gmail.com. So if anybody is interested, hit me up. That's my email.
Yep. For all your robotics consulting needs.
Or if you want to talk NASA or space.
So now, in a moment, as this deploys, you'll receive an email to confirm a subscription. And we'll actually see that as it comes up and it deploys these resources.
And I'll see that here on my side.
Oh, I see a comment here. Grand Beach Rentals is asking why they don't see the comments here on Facebook. So we're streaming out to multiple channels, to Twitch, Twitter on Periscope, YouTube, and Facebook. So if you want to watch this video later, it will be recorded on YouTube, but I encourage you to stay and talk with us. And if you have any ideas, I'm happy to switch what we're building a little bit up once we get to the different stage here. All right, so it looks like it is all deployed here. So deployed a function, our topic, and our managed policy. So Sammy will receive an email to approve that.
Just got it.
Perfect.
Confirm.
All right. So now we need to create so we have that policy. So before Soracom can even message this function, we have to create a permission. So we open back the AWS console, and we go to IAM, which is Identity Access and Management. Go to Users. I'm going to add a new user. And this is what gives us credentials, right? We create a user with this policy attached. I'm going to call it Sorel Livestream. Something, doesn't really matter. And we'll give it programmatic access. And then we attach an existing policy. Search. And we'll see which one is the one we just created. So we'll go back here. It is got the last 1KOP. It's this one, the live stream one. So yeah, we select that policy that we just created, and that policy gives it specific permissions just to that function and nothing else. Just go straight to review and create user.
And this is all on AWS's side, right?
Yeah, this is the AWS side, and so now it gives us an access key ID and access secret. And again, I'm going to tear this down afterwards, so don't try to steal these credentials. They'll be useless to you. So we go back into this configuration on Funk, and I'm going to drop this in the private chat for you as well, so you can configure it, Sammy.
Appreciate that.
Yeah. So we'll go into credentials here, add new credentials in the group. We select AWS credentials, drop the access key ID. We go back and grab the secret access key, which now the whole world knows about.
Don't forget to send it my way.
Yep. All right, and then we'll just give it an ID. We'll call it live stream AWS. tear down later. And then register. Cool.
Nice.
So now it has permissions to the message function, but it still needs to know where the function is. So we need.
By the way, sorry. Are we going to enable any of these other things like the air for cellular or endorse or Krypton? We got some cool names.
We won't be using those right now. So Krypton is a really great service, and we can dive into it a little bit later. But next step, we're going to use this Amazon resource name to tell it which function to message. So I've dropped that in the chat for you, Sammy. So then here, back in groups, we edit for the function arn. So that's all the configuration we need to do. And we hit save, and so that is good to go. So basically, we've got the unified endpoint working, we've got Soracom Func working, and if we want, we can also collect this data, any messages that come through, which we could then use later, either for like analytics or if you want to debug something, say like, your Amazon integration goes down.
You have unified input set to Func, right? Sorry.
Yeah. So you had that.
Yep.
And then I'm also going to enable Soracom Harvest Data. So hitting that means any message that comes out of that device gets stashed in the Soracom servers, so that you can use them later to create a dashboard or maybe another type of application. So yeah, right. Unified endpoint is configured, Soracom Harvest Data is configured, and Soracom Func is configured to a serverless app that we just deployed. Go back to this. And if we go back to our application here, we can also hit on that send alert function to take a look at that. So this is again that Python script I showed you earlier. You can actually edit it directly inline here. So again, it takes that event and passes it on. So now that we have that all going, now we work on the device side. So here's the fun part. You don't have to do any special configuration on your sketch. It just has to point at that endpoint and connect to our network. So going back to that repository under Arduino Sketch, and then Soracom Alert Func MKR 1500. Just gonna click on raw. Let's grab that all. I mean, actually, I already have it pasted here, but and then you just paste it into a new sketch in Arduino. So let's walk through that real quickly.
Yep.
I'm gonna increase the text size here. How's it look on your end?
It's looking good. I'm actually just going to save it. Let's give it a name. All right. Yeah, I also just grabbed a new beta of Arduino IDE 2.0, and it's fantastic.
Oh yeah, it's great. Like having the output in the serial monitor just on this tab right here is so good. For people who don't know, the previous Arduino IDE, you would click the serial monitor and open up with this little window, and it would just drive me nuts all the time. It's also way better, debugging, like new threads.
Oh yeah, I mean, you could never do this before. Well done, Arduino.
Yeah, they really outdone themselves. So, before we program it, we're going to take a quick walk through the code, right? So we have our includes for our libraries, our HTTP library that lets us handle REST requests in a much cleaner way. Arduino JSON, so we can actually create JSON objects and publish them. The MKR NB library that lets us connect using the narrowband modem, which in this case on the MKR 1500 is a U-Block Zara R410M. We set it to true to print AT commands, this is so we can debug what's actually going on the device. The way these libraries work is they send AT commands to a modem, and that's how probably most cellular devices work. So you have the modem is like self-contained, and then you have some device that's communicating with AT commands over serial and saying connect to this network or change profiles, things like that. We set our pin number to blank, so the Soracom sims don't, by default, have no pin attached to them. You can change that if you want to be like extra secure, but for default, we leave it blank. It's not built into this one right now. We set our APN, so this is the network. This lets it know when it connects that it's looking for the Soracom network. And then it registers as username Sora, password Sora. And for those who are concerned about security, you can set in Soracom to have an IMEI lock so that your SIM card is locked only to your specific device, so that you know that nobody can take that SIM card out, put it in their own device, and steal your data. Then we set our server. So this is the endpoint URL is the unified.soracom.io, and it's on port 80. We create our narrowband client, we create a GPRS object, narrowband access, and then we say that for when you initialize the HTTP client library, so that REST wrapper, use the narrowband client. So in that way, you can call for that. We initialize our ultrasonic sensor. It's on pin 1, which we defined. And we set our alert range here. So I've set it to 10 centimeters. So that means basically you have to be like right against this ultrasonic sensor to trigger a REST request. And then some other stuff just to handle connection and timing. If you're in the setup, so Arduino sketches are you have a setup and then you have a loop. So the setup function happens once at the beginning. This is where you do initializations, and then you have a loop that runs continuously. So in our setup, we just do a couple of things like reset the pins for the modem. So this is just something that you have to do that's very specific to this particular modem. We create a serial connection so that we can monitor what's going on. And I have this while loop in here. You can remove this. This is just for if you don't want stuff to start before you've made a serial connection, because otherwise it's going to start sending like logs and you won't know that what stage it was at. And then we start and connect modem. So I have actually these functions down here. And start connect modem just goes through the library specifics, along with a couple of really weird little things we have to do for this modem, where you have to kind of set it and lock it into a certain band, just because narrowband IoT can be particular. So we've got these AT commands that basically reset it and set it to profile mode 0. Then we connect the modem, it creates this connection object, and then boom, it's connected. And then all the magic happens in this loop really here, where every time it loops, every 50 milliseconds, it grabs the range from the ultrasonic sensor, logs out that range, checks if the network access is still alive, checks if it's been at least a second since the last message, because you don't want to just like send a billion messages when you touch it because it's going so fast. And then we say when the range is below the alert range, so if it's below 10 centimeters, then we reset the last sent time. We create a JSON object that has the time this message is sent and the range that it detected. Creates that JSON object and then calls the post data function we have here, which uses the HTTP library to make a REST request to the unified endpoint. And then all the Soracom network magic happens, right? You go tunnel into our network, goes to Soracom Func, hits the Lambda function, sends an email out to Sammy's email address. So with that, now we can do the flashing part. Again, there's no credentials you need to add in here. That's your SIM card. So Sammy, do you have it set? Ready?
I need to plug it in. I don't know if you guys sent me a USB cable, so I'll just have to go delve into my stores of hundreds and hundreds of them. There we go. Just got it plugged in.
Yep, so plug in the USB. We've got our SIM card inside it already. And then go ahead and grab that ultrasonic rangefinder from your kit and a growth cable and just plug it into what's marked as D1.
D1, great. And what orientation do you that's actually pretty easy to see.
Yeah.
Ready?
Yeah,
setting it all up.
Oh yeah, when you're putting the board into the carrier, you wanna make sure that it's lined up with all the pins. You can use. I usually just use like A ref matches to A ref on here.
Yep. Ground matches to ground. Power matches to power.
Exactly. And then we plug it in. We've got our sketch here on the IDE, and we just hit upload, which will compile the sketch, make sure there's no issues with it, verify it, and then we'll upload it. And of course, we've set in our port, we've set go to tools, select which port it's on. It is so fast. On the previous IDE, this took like at least a minute. antennas in, and then we go to the serial monitor here. Oh, it popped out for some reason. There. All right, so it's attempting to connect, but unfortunately I'm inside, so it can't detect anything. So I'm gonna step up for a second.
Do you have your antenna connected?
No, I didn't get the big antenna hasn't come in yet. Actually, let me check. Maybe it just got here. Nope. So I'm gonna just plug this in my USB extension and take it outside. We're doing it live.
Now, one thing I want to say is, I don't know if you can hear me, Moheeb, but I'll wait till you're back. But I've got the board plugged in, it's connected, my computer's installing the drivers, again, doing everything from scratch. So I'm in the same boat as any of you would be if you were getting these.
All right, I'm back. So I'm gonna just tap this and re-plug it in so we get a new update from that. Let's see if we have any comments. I don't know what this says, and I hope it's something nice.
We're just gonna pretend that it is.
Yeah.
You know, I wanna say something quickly. You know, I work in robotics. I've been doing this for a long time, and one of the hardest things I've found has actually been trying to get a good cellular connection for product that's out in the field. For example, a drone or a robot. Just because buying a modem off the internet, specing one is difficult. Getting a data plan with one of the big three or big four companies is difficult. AT&T, Verizon, T-Mobile, Sprint. This makes it so much easier. I can literally throw one of these things on one of my drones, and out in the field, I can have internet connection anywhere. Once there's coverage. So I think this is really great. Soracom, I really appreciate this. This product looked awesome. Can't wait to get it running here in a second. And hit me up. Maybe I want to throw this on a few drones, do some testing out in the middle of nowhere.
Yeah, that could be a lot of fun. I'd be excited to see that. All right, so while we're talking, it actually did connect. This is a first for a great connection on the first try of the live stream. I probably just jinxed myself for calling that out. But if you saw what happened here, right, is I turned on the modem, it set the APN and the user and password, and then you see all these AT commands, right? This is the CRED thing, it's looking for a network. So usually when you start it up, at first if you don't have a good signal and it's not seeing towers, you'll get 0, 0. But once it starts to find stuff, it'll go to 0, 2. And then usually around like 0, 5, if you get a 0, 3, that means it didn't connect. But 0, 5 means it's found a tower and it connects, and then you'll see a bunch of crazy commands coming through. So if we actually saw, I think I may have accidentally put something above the sensor because it just triggered. So if you check your email, you probably just got a notification.
Yep, let's see. Just plugged in the ultrasonic sensor. It built and deployed the first time. That's fantastic.
Awesome. I'm going to be right back, and I'm going to go check the device, which is outside. So yeah, it should receive a message that just has the JSON object in its body.
Oh, in my email. Mm-hmm. Let's see. Go looking for that. I got mine running. I see a lot of the stuff printing to serial monitors, so the modem was set to default. AT commands have been sent. It is attempting to connect to GSM. You know what? I got this nifty PC antenna you guys sent me. I should probably plug this in.
Yeah, the antenna is very important. That is one thing I've definitely learned is, that the antenna we include will probably work for most situations, especially if you're in an area of coverage. But if you're like me, you're going to have to end up either putting it out somewhere specific, but if you're trying to work indoors.
Question. Did I use one of these bad boys?
Yeah, if that antenna will connect, maybe. I ordered a large one that has like an SMA adapter for the board, but it's this huge like mountable antenna that's probably used for who knows what. Yeah, so that sent that message, and I'm gonna open up. One of the cool things is we can go back to the function, right? So we're at the page for that function and hit monitor. We can view the logs in CloudWatch, and if
I,
things worked correctly with the user permissions and everything, we'll see if that message went out or not. So it did receive it. So yeah, it had detected something on it, and we see the message came here in the event body. So one, it detected a range of 5 centimeters, that's below the 10. It sent out, it published that message to SNS. So we can actually observe this behavior directly. So when you go down here to the code tab, you can hit test and create like a fake event. And it doesn't really have, it can be an arbitrary event. We haven't put any particularities in it, so we can just go with the default test event. Create that. And then we can hit test, and it'll go and show us the execution result of this function. One of the cool things about this is you don't have a server running. You have this function that lives and dies when it's necessary. Oh, Sammy, you're saying you didn't receive the email?
I have not, but so I'm redeploying stuff to my board. As soon as I plug in the PCB, it connected, and I'm getting a bunch of stuff printed to my screen.
Oh, wow. Did you get... if you go put your hand over the over the ultrasonic sensor, you should see it log out something like posting data.
Got it. Let's see.
Yeah.
I'm actually going to redeploy everything, make sure that's all fine and dandy.
Okay, while you do that, walk through this. So yeah, we sent in this test
Oh,
result.
there we go. I got the email.
Oh, nice. Awesome. Yeah, and then we look here, right? This is what that log looks like. So this function is really simple. So now, first off, we're going to celebrate. We got it deployed where we have a remote device connecting over the narrowband IoT band to Soracom's network, privately going to our cloud, authenticating through the SIM card. When the rangefinder detects like my hand over it, it sent a message. It posted to the unified endpoint, went on the Soracom cloud, which then forwarded to Soracom Func through a Lambda function that we just deployed. And then that Lambda function sent an email out to Sammy. So that right there is pretty cool. Now that's a sensor that can create a remote alert. It's a very basic alert, an email. We can build on that. So because this is Python and a number of the core Python libraries are included in this Lambda functions environment, we can do something like post that to another service. So what I did the other day is, I'm going to stop sharing my screen for a sec. I created a Slack workspace, particularly just for this, so we can do a Slack integration.
Oh, awesome.
All right.
Can I set one of these up to Slack me every time one of my employees gets up from their desk?
Yeah. You could. You totally could. We had a system at a previous startup I was at. We set up a device to, and that was over Wi-Fi, to use like a magnetic read switch on the bathroom door, because there was one bathroom in the startup. So whenever somebody opened that door, it would send this like Rube Goldberg machine of cloud stuff to turn on a big siren light. So you always knew when someone was in the bathroom, but it was funny. All right. So I'm gonna share my screen again. So I made this like just blank Slack workspace, and Slack is notorious, well known for making it very easy to add all sorts of integrations. So when you're in a Slack channel, you can go in and add an app, and the one we're using is called Incoming Webhooks. So I've already added this app to my workspace, and we can configure it and create a. So webhook is just it's a REST endpoint. It's usually a single endpoint meant to hook into something, so like an API or something like that sort, because there's all these different tools that let you do quick integrations with just the webhook. Like GitHub has webhook triggers, where if there's an event that occurs on a GitHub repository, like a new branch or a new release, you can have that webhook kick off to something else. And normally that's what you would use this for. But instead we're going to do a direct device, or any device within that group that we created on Soracom, on the Soracom cloud, can now publish into a Slack channel. So we hit add to Slack, and we choose a channel. In this case, I'm just going to do shenanigans. And then we'll say add webhook integration. Let's see how much time we have before. All right, so it actually just creates a single webhook URL for us. So if we were to post to this endpoint, we can send body of text. So I actually wrote a little bit of this earlier. So grab that and go back to our serverless function. Again, you can edit it directly in here. I'm gonna see if I can increase the text. There we go. So in here, it's importing a couple of things, right? It's Boto3 is the AWS specific library, so that we could publish to SNS, but we're going to add URL lib3. So recently, AWS removed the requests module from the Python distribution. So in lieu of using URL lib3, so not super familiar with the specific one, but it's fairly straightforward to make a REST request. So we import that module so it has it, and then right after it does this function here, which makes the message to SNS, we're going to add in this horrible blob. Let's just format it. Oh no, they don't have hotkeys in here. I'll just tab that manually. So right, we include the URL lib3. That's kind of like just like the library we put in on the Arduino sketch. It's a helper library for making REST requests. And we say create this HTTP object, and the data we send it is a JSON object that says, okay, our channel, which is shenanigans, and our username, which can be arbitrary. This is just what we're going to call the fake user that's messaging. And our text is just going to be the event that came in. So JSON dumps is a function that takes a JSON object, turns it into a string, so that the API here can handle it. And then we're going to say create an icon emoji. So this will be the user's face. No. Hopefully it saved all that. Oh, great. All right. And then we encode that data. Right. And then we make our request. And in here we need to give it a URL. So we go back to the Slack webhook. And we copy that webhook. Actually, I'm going to go ahead and save this so that we have it. Just paste that in. So this is using that app that was already there. You can edit it in line. And that should be all we need to do. So if I hit deploy, that function's now live. And so if I hit test, oh, there's a syntax error. What have I done? No encoding declared. I've done something horrible somewhere. There's this. Yeah, I think you have. Python is very particular about indents.
Yes. Quick question. I think I saw in this Grove kit a GPS sensor. Is that right?
Yeah. So that GPS is it just plugs into the serial port, or next it might be labeled differently.
Yeah, it's either TMI. No, serial. Yeah, serial. Bottom left-hand corner.
Yeah. Yeah, that's right. TWI is actually the I2C port, but it's called TWI for reasons unknown to me. Okay, I'm gonna cheat, and I had already written one. So here's one we did earlier. Oh, let's check what's going on in the comments. I'm not going to answer this, Chloe. Okay, we have a question here. How to send AT commands by using Arduino. If we go back to the sketch here, there's actually an example of us doing this. So the mkrnb library has a modem function you can just call, or modem object, and it has or class, I forget which, and it has a function called sendf, and so this lets you actually just directly send an AT command in line, and then you can set a wait for response, which basically it's like a delay or blocker that says don't do anything else in this sketch until you receive a response back from the modem, whether that's a good response or a bad response. It'll just output all of that, particularly if you have the print AT set to true. So like when we create the access for the client for narrowband, we actually just pass it true or false, which is an optional value, but it defaults to false otherwise. So that's the way you can send AT commands. All right, check that hook again, and then we're going to change that channel back. And then change that to ghost. Oh gosh. All right.
So I'll say, I mean, setting up and
Cool.
connecting this modem, super easy. Really nice.
Hey. Hey, look at that. So we just tested the function, and this is what it would look like. We get the Sorabot replies back. And this was just testing to the Lambda function, but since we know it does work from our device, it should do the same. So Sammy, is your device connected?
It is, and actually, you know what? That's the exact same message I just got in my inbox.
Oh yeah, because I tested it, and this is the Lambda functions tied to your email. But you've configured the group and Soracom Func and all that?
Yeah, believe so.
And on your console output for your Arduino, is it reading out the rangefinder values?
It is not.
So it hasn't connected yet. That was my concern. Maybe you haven't connected yet. What are you logging out there?
Just the I get the OK, I get the AT plus CE reg question mark, and then I get a plus CE reg value of 0,0. Maybe it's just not a good connection.
Yeah, so that means it's likely not seeing a tower. So if it were starting to get close to connecting, again, some of this is like wishy-washy guessing by me, but
No, I mean, here,
if it's 0,2, it means it's seeing stuff.
All right, let me go, and I can walk it to the window, and then unfortunately I will have to say my goodbyes in about 5 minutes.
Yeah, well, why don't we let you go now, and
Okay.
we can debug that on the side, but I think we've gotten to pretty much where we needed to get to, right?
Yeah, the modem stuff and everything, super easy to get running. This is fantastic.
You know, which I just got a message that my antenna just got in the mail. It's here.
I might have to get one of those beepy antennas myself.
Yeah, it never hurts, especially because it's hard to know what coverage is or what issues you're dealing with, right? Like this is a problem that a lot of people have found solutions for.
Oh wait, I definitely had 1.1, and I had measurements early on. So I'm definitely connected, but then I think I just lose connection, so it's probably not super strong.
Okay. Yeah, indoors it's a little tricky. With the GSM 1400, I think since that does 2G, 3G, 4G networks, it's more likely to work indoors because if your phone works indoors, then that'll probably work. But
Yep.
narrowband is a little bit trickier, but when it does work, it works great, and it's can be really reliable in comparison.
Awesome. Soracom, hit me up. Send me one of those other ones. I'll test it out. I'll come back some other time.
Right on. Is there anything you want to say before we let you go? Like, where can people find you?
Oh,
They already have your email now.
yeah, that's my email. You can hit me up. I probably should have added it to my name here. You can find me on Twitter. Just search my name, or at stmian17, or on Clubhouse. Find me on Clubhouse, smian. I'll talk to you about NFTs and about aliens in space.
Yeah, did you say it's STMIAN?
Nope, just SMIAN.
17 on Twitter?
Oh yeah, STMIAN17. Here, I'll send it to you.
Here we go. I got it right here on screen.
Oh, you're missing the T.
Oh,
Sorry.
STMIA.
Yep. 17.
All right, there we go. So if you want to find Sammy, find him there. Seriously, he does amazing work. He's worked with NASA. He's worked with this robot stuff at ASU. I remember you were always doing something. So uh, always happy to see you.
Yeah,
All
awesome.
right,
Thanks for having me. This was great. Thank you, and thanks Soracom for the free kit and for the fun experience.
awesome. Thank you, Sammy. We'll see you another time. Hack the planet.
Thanks.
All right. So with that, if there are any questions, please drop them in the comments. I'm just going to go do a quick walkthrough again of what we just did, and then we'll probably end the stream there because we are at the top of the hour there. So let's see here. All right. So we started with, we create a SIM card. We created a group for it. We enable Soracom Harvest and the unified endpoint. We enable Soracom Func by deploying a serverless app just using the serverless application repository by doing a one-click app creation, which again, you can go to this repository in GitHub and look at how that's put together. And if you want to know more about how to deploy or create apps in this way yourself, the thing to look for is the AWS Serverless Application Model, SAM. So this is a SAM template, which is a variant of CloudFormation. So that was used to create a serverless function, an SNS alert topic, simple notification service to subscribe to an email address we provided. It also created a managed policy for us. We created a IAM user in AWS. We attached this managed policy to it, which only gives it the access to invoke this specific Lambda function. We added that into the Soracom Func configuration. And then we programmed this sketch onto our Arduino, which tells it to connect to the Soracom network over narrowband IoT using the MKRNB library. There's also a version of this sketch for the MKR 1400 if you got that version of the kit. It connects to the Soracom network and then periodically checks the range value on an ultrasonic sensor. When that gets below 10, or you can change that value up here in the range. And then once it detects that, sends a message out to the unified endpoint, gets forwarded to Func, goes to the serverless function, sends the email, and then we edited that function in line through the AWS console to send a REST request using the URL lib3 to a Slack webhook so that any event that comes in from this device, like if it's ever triggered or alerted, you can have that go into Slack. And of course, you can customize that message that gets sent out here. So you could say, like, if it's a specific key value, you can do different conditions. Like if you got like alert red or blue, or say the temperature was important there, you could do something with that and create an actual, real message. Yeah. Chloe is asking if this is an AMA. You can ask me anything as long as it's somewhat related. Well, yeah, so we did that. And you could build all sorts of things with this, right? You could have a Slack channel dedicated for, crisis recovery. So if you work in a data center, you could set up a remote data center even. You could set up a self-contained sensor module that if anything else fails in there, that module's still working on its own sandbox connection that's secure and could detect, say, an earthquake through accelerometer values, and you use edge impulse to make machine learning models that run on your device that know specifically what kind of event is occurring. Or you could have a temperature sensor and say the server room's overheating, send that alert out to your Slack channel, and then everybody can go deal with it. Chloe asks, what is my favorite robot? Oh, that is easy. Johnny 5. That movie inspired a lot of my shenanigans, which is why you see parts everywhere. Automatones. Oh, speaking of robots, next week, so I'm going to probably end the stream here since we just hit 2, but next week I'm going to work with the NVIDIA Nano Jetson. So this is a single board computer that is optimized for AI and machine learning. and I've got it on this Jetpot kit, so I'm really excited. So we're going to connect this up to the Soracom network using our Onyx dongle, which is a USB modem that works with the Soracom network. So tune in next week, same time, to have fun with us when we build that. So with that, thank you again, everybody, for all of those who stuck through the live stream. I hope it was educational. Feel free to reach out to me at VirtualVox on Twitter, Instagram, and Clubhouse, wherever you are. I'm happy to hear from you. And be sure to check out Soracom.io. Go to our shop. Again, we have 40% off on our kit, so it's an opportunity to get started with IoT. So with that, I will sign off. So cheers and heck.